The biggest blocker to AI automation of companies is no longer the models, because they just got so good so quickly. Now, the real blocker is the domain knowledge inside companies.
On Y Combinator's Summer 2026 request for startups, Tom Blomfield names what he wants founders to build. His exact words: "We need Gary's G-Brain, but for every business in the world." YC just declared a new investable category. The CEO of YC already shipped the personal version, open source. The question isn't whether they're right that companies need a brain. It's what's actually inside and what's missing for it to scale. Garry Tan is the president and CEO of Y Combinator. Tom Blomfield is a YC General Partner, the founder of Monzo and GoCardless before that. When YC's CEO ships open source code and a YC partner names that exact code as the prototype for a category they want to fund, that isn't coincidence. That's a thesis. The repo is called G-Brain. It opens with this sentence: "Your AI agent is smart but forgetful." G-Brain gives it a brain. The numbers Tan publishes alongside it: 17,888 pages, 4,383 people, 723 companies, 21 cron jobs running on schedule, built in 12 days. Not a demo. Production data, his own. What G-Brain actually is, in plain terms: Markdown files on disk are the source of truth. A retrieval layer, Postgres with PG vector, or an embedded version Tan calls PG Lite, sits on top. 29 Markdown skill files tell the agent how to use it. And a process he calls the dream cycle runs while he sleeps. In his words, "I wake up and the brain is smarter than when I went to sleep." Here's the gap, stated up front. G-Brain is a personal brain. Blomfield is asking founders to build the company version. One user with one brain, solved. Many users with shared brains, not solved. That gap is the entire investment thesis. We'll come back to it. First load-bearing claim: knowledge graphs beat vector retrieval. The kind of question vector search struggles with "Who works at Acme AI?" "What has Bob invested in this quarter?" is a relationship question. Cosine similarity over text embeddings doesn't reach those answers. A typed link traversal does. On every page right, G-Brain extracts entity references with regex. It infers typed edges, attended, works at, invested in, founded, advises, from the page's role and the surrounding text. Zero language model calls. The graph wires itself, on the cheap, on every save. The number that matters comes from his benchmark, BrainBench. 240 rich prose pages. Precision at 5 hits 49.1%, 31.4 points higher than the same codebase with the graph layer disabled. Same corpus, same embedder, same pipeline. Only the typed link extract changed. The transferable principle: the graph wires itself, regex over language model, where it can be. Second load-bearing claim: Tan's exact phrase, "Skill files are code." The runtime is dumb. The intelligence lives in Markdown. A human can read, version, and audit. 29 of these skill files ship with G-Brain. A single file routes intent to the right skill. It's literally called the resolver. There's no orchestrator, no planner, no chain. There's a flat directory of fat Markdown files and an agent that reads the right one when it has a task. Why this matters: most agent frameworks bury their instructions in code. You can't read them. You can't review them. You can't change them without a deployment. Tan's bet is the inverse. If you can't read your agent's instructions, you don't own them. The transferable principle: plain text outlives code. Third load-bearing claim is a benchmark. Tan ran a real production task. Pull a month of his social media posts from an external API, ingest them end-to-end into the brain. Realistic load, 19 cron jobs in flight. He compared two routes. 1. Spawn a sub-agent to do it. 2. A deterministic background job he calls a minion. The numbers, side by side. Sub-agent, over 10,000 milliseconds, Gateway timeout, token cost, roughly 3 cents per run. Success rate, 0%. The subagent couldn't even spawn under load. Minion, 753 milliseconds. Token cost, 0. Success rate, 100%. The routing rule Tan extracts. Deterministic work goes to minions. Judgment work goes to subagents. Most of what we call agent work is the first thing pretending to be the second. The transferable principle. Determinism is a routing decision, not a fallback. Fourth piece. The dream cycle. 8 phases that run on a schedule while the user sleeps. Lint. Backlinks. Sync. Synthesize. Extract. Patterns. Embed. Orphans. None of these is novel on its own. The interesting thing is what the pipeline does to the data over time. Overnight, conversation transcripts get distilled into reflections. Cross-session reflections aggregate into long-term patterns. Tan calls them 25-year patterns. Citations get audited. Orphan pages get relinked. Stale embeddings get refreshed. The brain isn't searched at the end of this. It's reorganized. Why this matters. A static knowledge base ages. The pages you wrote 2 years ago drift away from the pages you wrote yesterday. A self-maintaining one compounds. Most knowledge tools degrade with use. This one appreciates. The transferable principle. Memory should be a process, not a snapshot. Step back. Most failures we blame on AI agents aren't intelligence failures. They're 2 distinct architecture mistakes, and naming them is the load-bearing move. Better models don't fix what better routing and better memory should have fixed already. Mistake 1. Amnesia. Agents have no persistent world model. Every session starts cold. Tokens get spent every conversation re-establishing context that should have been written down once and indexed forever. Vector retrieval patches this badly. Fuzzy recall, no relationships. Knowledge graphs patch it well. That's the world knowledge layer. Mistake 2. Misrouting. Deterministic work gets sent through a reasoning model because the framework doesn't distinguish between work that needs judgment and work that just needs running. Tokens get spent on a decision that wasn't a decision. Subagents stall under load. Minions don't. That's the operational logic layer. The architect's question isn't, can my agent do this? It's, should it? Memory is one layer. Routing is another. Tan's bet. Separate world knowledge from operational logic. Markdown is durable. Chains aren't. What changes if Blomfield is right and the company brain becomes the default substrate for AI automation? 3 things shift. First, vector databases compress as a category. Knowledge graphs replace them as the default substrate. The reason vector retrieval dominated 2023 and 2024 was simple. It was the only thing that worked. Once typed link extraction at scale is a solved problem, the comparison ends. Second, orchestration frameworks built around chains of language model calls become legacy infrastructure. The same way object relational mappers displaced query builders. The framework that makes the agent dumber wins. Third, subagent spawning gets a minions filter in front of it. Token bills drop. Probably somewhere between 50 and 80% on workloads where most steps were queued, shell work pretending to be reasoning. Where the thesis might break. GBrain is personal. One user. One brain. Multi-tenancy. Access control. Right conflict resolution. Consensus across teams. Tan hasn't solved any of those publicly. That's exactly the gap Blomfield is paying founders to close. YC isn't betting on a product. They're betting on a stack. Company Brain is one of 4 pieces named in their summer request for startups. Tan shipped the only piece YC built itself. Architect's lens takeaway. 3 points. First, memory is the leverage layer. If your stack doesn't separate memory from reasoning, you're paying tokens for state. Second, determinism is a routing decision, not a fallback. Most agent work is queued shell work in disguise. Third, Markdown outlives code. Skills you can read survive longer than chains you can't. Subscribe for the next autopsy.